Indexing security using Java. Introduction. Indexing security is the practice of securing indexed data structures, database indexes, search indexes, and application-level indexing mechanisms to protect sensitive information and maintain system performance. For Java developers, indexing security is important in PostgreSQL, Oracle Database, Elasticsearch, OpenSearch, Hibernate, JPA, Spring Boot applications, search engines, data warehouses. A common interview topic is, how do you secure indexed data in enterprise Java applications? This guide explains database indexing fundamentals, index security risks, Java implementation considerations, search index security, encryption strategies, access control, audit logging, secure indexing architecture, real-world examples, best practices. This is an important topic for backend developers, security engineers, and system architects. Simple definition. Indexing security means protecting indexed data from unauthorized access, leakage, tampering, and performance attacks. Why index security matters. Indexes often contain customer information, email addresses, account numbers, transaction references, searchable business data. Without security, sensitive data can leak. Attackers can enumerate records. Search systems may expose private information. Compliance violations may occur. What is an index? An index is a data structure that improves query performance. Example: create index IDX user email on user's email. Without index, full table scan - slow queries. With index, B-tree index, fast lookup high-level indexing architecture, Spring Boot API, Hibernate JPA, database indexes, common index types, index type usage, B-tree general searching, hash index, equality lookups, full text index, search engines, bitmap index, analytics, vector index, AI search, composite index, multi-column queries. Security risks of indexes. Indexes improve speed, but introduce risks. Examples: UX information disclosure, UX inference attacks, unauthorized searches, index poisoning, data leakage. Example security problem. Table, users, columns, ID, email, salary, SSN. Index, Joe. Create index IDX SSN on users, SSN. Risk. Attackers may target indexed sensitive data. Principle of least privilege. Very important security principle. Users should only access content, required data, required indexes. Never expose administrative indexes publicly. Secure database access. Java architecture. User, Spring security, service layer, repository layer, database. Security checks should occur before index access. Example Spring security protection, @preauthorize, has role admin, public list user, get users, return repository.findAll. Benefits: controlled index access. Protect sensitive indexed fields. Avoid indexing. Passwords, access tokens, secrets, encryption keys. Bad example: create index IDX password on user's password. Never do this. Secure search indexes. Search engines. Check. Elasticsearch, OpenSearch. Often contain customer records, documents, audit logs. Search index security architecture. Users, Spring Boot API, authorization layer, Elasticsearch. Never expose Elasticsearch directly. Secure Elasticsearch access. Bad. Internet - Elasticsearch. Good. Internet. API gateway, Spring Boot, Elasticsearch field level security. Some users should not view certain indexed fields. Example: Name, John. Salary, 100,000. Normal users. Name, John. Admin users. Name, John. Salary, 100,000. Data masking. Sensitive indexed values should be masked. Example, 1, 2, 3, 4, 5, 6, 7, 8, 9. Display. Task, 6, 7, 8, 9. Java example. Public string mask SSN, string SSN. Return top SSN.substring 7. Encrypt sensitive data. Very important security practice. Example. Database dash encrypted fields. Benefits. Check protects stored data. Java encryption example. Using AES. Cipher equals cipher.getInstance. AES. Applications. Check PII protection. Check compliance requirements. Indexing and GDPR. Sensitive information must be protected. Examples. Names, emails, addresses, personal identifiers. Requirements. Controlled access. Deletion support. Auditability. Secure JPA queries. Bad. String SQL equals select star from users where email equals email plus. Risk. SQL injection. Safe query example. At query, select u from user u where u.email equals email. User find by email. At param email. String email. Benefits. Check parameterized access. Search result security. Users should only retrieve authorized data. Architecture. Search request dash authentication dash authorization dash search execution multi-tenant security. Common SaaS requirement. Example. Tenant A, tenant B, tenant C. Users must only access their tenant data. Multi-tenant query example. Find by tenant ID, long tenant ID. Benefits. Check tenant isolation. Audit logging. Track indexed data access. Log. Crick. User, search query, result count. Architecture. Search request, D. Audit log, database Java, audit example logger, .info. User $searched for, username, query. Benefits. Check compliance. Check investigations. Rate limiting. Protect against scraping, brute force searches, enumeration attacks. Architecture. User, rate limiter. Search system, Spring Boot, rate limiting. Popular solutions. Cuck Bucket4j, Cuck Redis rate limiting. Cuck API gateway throttling. Indexing security in Elasticsearch. Secure. Check indices, aliases, documents, fields. Best practices. Authentication. TLS, RBAC. TLS encryption. Secure communications. Example. Spring Boot. HTTPS Elasticsearch. Benefits. Encrypted traffic. Secure index maintenance. Monitor. Unused indexes, oversized indexes, unauthorized modifications. Benefits. Improved security. Better performance. Real-world example. Banking application. Architecture. Mobile app API gateway Spring Boot PostgreSQL indexed customer data, indexed fields, customer ID, email, account number. Protected by RBAC, audit, logging, encryption, API authorization, search security flow, user search, JWT validation, JWT role validation, search query, filtered results. Common security vulnerabilities. 1. SQL injection. Allows unauthorized index access. 2. Exposed search clusters. Direct Elasticsearch access. 3. Missing authorization. Users see unauthorized records. 4. Sensitive field indexing. Leaks confidential data. 5. No audit logging. No traceability. Common beginner mistakes. 1. Indexing everything. Not every field needs indexing. 2. Indexing password fields. Never index passwords. 3. Exposing search engines publicly. Always place behind APIs. 4. Ignoring multi-tenant isolation. Creates data leakage risks. 5. No encryption. Sensitive data remains exposed. Best practices. Click. Index only necessary fields. Click. Avoid indexing secrets. Click. Use Spring Security Authorization. Click. Encrypt sensitive information. Click. Implement audit logging. Secure Elasticsearch OpenSearch clusters. Click. Use TLS everywhere. Click. Apply rate limiting. Click. Monitor index usage. Click. Follow GDPR and compliance requirements. Common interview questions. 1. What is an index? An index is a data structure that improves query performance by enabling faster data lookup. 2. Why can indexes create security risks? Indexes can expose sensitive searchable data if access controls are not implemented properly. 3. Should passwords be indexed? No. Passwords should never be indexed and should always be securely hashed. 4. How do you secure Elasticsearch? Use check authentication, check RBAC, check TLS, API layer protection, check audit logging. 5. How does Spring Security help indexing security? Spring Security enforces authentication and authorization before index data is accessed. Enterprise Secure Indexing Architecture users. API Gateway, Spring Security, Spring Boot Services, Repository Layer, PostgreSQL, Elasticsearch, Encrypted Index Data, Audit Logging. Final summary. Indexing security is a critical part of enterprise Java applications. Important concepts include check database indexes, search index security, authorization, encryption, audit logging, multi-tenancy, rate limiting, GDPR compliance, secure Elasticsearch deployment. Java developers should focus on secure data access, Spring Security integration, search security, encrypted storage, auditability. Key idea. Indexes improve performance, but every indexed field becomes a potential security target. Secure indexing requires proper authorization, encryption, auditing, and controlled access throughout the entire Java application stack.